Hi everyone, welcome back. Today we're going to take a look at lesson 17B, and I wanted to take an opportunity to go through some quadratic word problems with you. So we're going to practice 6 examples here, and often when we're working with word problems, it's helpful to make a sketch or draw a diagram. Sometimes that'll apply, sometimes it'll be a little more difficult, but let's get started and see how these problems go. All right, so the first one we're going to take a look at, let me zoom in here, is the garden plot problem. So if we read through this, the garden plot, a rectangular community garden, has an area of 40 square meters. The length of the garden is 3 meters more than the width. Find the dimensions of the garden. So a couple of things to remember here. Number one, I think this is an easier problem to draw a quick diagram. So let's draw a rectangle for our garden where we have a length and the width. So the width here, the length is going to be the longer part, and it says the length of the garden is 3 meters more than the width. So if the width is W, the length should be equal to W plus 3. And that is a really important piece of information. Okay, so if we want to find the area, hopefully we recall that area is equal to length times width of a rectangle. So let's start filling in numbers for the variables. Well, we know that the area here is 40. And so instead of A, I'm going to rewrite 40. Then we know the length is W plus 3. And then the width is just W. So we'll start working through this equation that we've developed. So 40 equals, I have a binomial times a monomial. I'm basically going to use the distributive property. So I'll have W squared plus 3W. If you notice, we almost have a quadratic that we can set equal to 0 and solve. So all we need to do is move that 40 over to the other side. And don't forget to change the sign. So if we get rid of that 40 on the left, I'll be left with 0. And over on the right, I'll have W squared plus 3W minus 40. And what we have here is a quadratic that we can factor. So it's up to us now to find two numbers that multiply to give you negative 40 and add to give you positive 3. On the side, we can start to think of some of our factors. It needs to be a negative 40, so we have to think of the positives and the negative situations. And we can start with, let's say we start with 2 and negative 20. We also want to consider negative 2 and positive 20. Neither of those seem to work. What about 4 and negative 10, or negative 4 and positive 10? And those don't seem to work. Again, we're trying to add, have two numbers that add to give me positive 3. So how about 5 and negative 8? And we're actually almost there because that'll give me negative 3. So let's change the signs. Negative 5 and positive 8. So these are the two numbers that will multiply to give me negative 40, and they will add to give me positive 3. Now I have the factors, and I rewrite my quadratic in factored form. So we'll have W minus 5 and W plus 8. Now to solve this, we consider the zero product property, which states that if A times B equals 0, then A could equal 0 or B could equal 0. This zero product property allows us to take each factor, so W minus 5, and set that equal to 0, as well as W plus 8, and set that equal to 0. What we're doing is we're solving for two possibilities of W, and the width here would become positive 5. And on the other side here, the width would be negative 8. So let's consider the context of the question. We are trying to solve for the width of a garden. We know that the width of a garden, well, it can't be a negative value, so we don't use that value. So even though it came out to be one of the solutions, in the context of this question, it doesn't make any sense. So our solution really is for the width of the garden is 5. And in this case, 5 square meters. All right. Let's take a look at another example. So in this example, a smartphone is dropped from a balcony. Its height h in feet after t seconds is modeled by the equation that's given. H, the height, is equal to negative 16t squared plus 64. How many seconds will it take for the phone to hit the ground? So right here, this is an important piece of information. Hitting the ground. When the phone hits the ground, the height from the ground, h, is going to be 0. So that helps us in terms of our quadratic. We change and we substitute the values into the quadratic. H on the ground is 0 minus 16 t squared plus 64. We don't quite have a 3-term quadratic, a trinomial. We have a binomial. If we take a quick look at it, we can deal with this just by a common factor. So let's take the common factor of negative 16 out. I'll be left with t squared minus 4. Our zero product property says that I could take one of these factors out and set it equal to 0. So we're going to take t squared minus 4 equal to 0. When we solve this, we'll move that minus 4 or negative 4 over to the other side, and we'll have t squared is equal to positive 4. And then to solve for t, we take the square root of both sides. So t is equal to plus or minus 2. Remember, when we take the square root of a positive whole number, we always have a positive situation and a negative situation. But let's see what makes sense here, right? Can the time equal positive 2 seconds? Or can the time equal negative 2 seconds? Again, in the context of this situation of the falling cell phone, we can't have a negative 2 seconds. So that doesn't make sense, and it will take 2 seconds for the cell phone to hit the ground. Let's move on. So number 3 is the framing project. A photographer is framing a square photo, key piece of information. She decides to increase one side by 4 inches and the other side by 6 inches to create a larger rectangular frame. The area of the new frame is 120 square inches. So what's the side length of the original square photo? Here it's a good idea, again, to draw a picture. So we initially started, this is my best attempt at a square, with a square photo with the side lengths of S. I put square all 4 sides. Now, the framing or the photographer wants to add 4 inches to one side and 6 inches to the other. So here, move up a little bit. Let's say this is the side where the photographer adds 4 inches. And then over here, I'll draw a bigger arrow, and this is the side where the photographer adds 6 inches. Again, dealing with a rectangle and dealing with area, we have to recall our formula for the area of a rectangle. It's length times width. And let's not forget that the area was given. It's 120 square inches. So we'll start to replace the variables with the information that we have. Area is 120. That's going to be equal to the length, in this case, is the S plus 6 times the width, which is S plus 4. We have two binomials multiplied by each other. We can remember the acronym of FOIL. That might be helpful. So let's go ahead and expand. 120 is going to be equal to S squared plus 6S plus 4S plus 24. Let's simplify by collecting the middle terms. 120 is equal to S squared plus 10S plus 24. In order to solve this quadratic, we have to take that 120 over to the other side, and that helps us set one side of this quadratic equation to 0. So 0 will equal S squared plus 10S. Then we have 24 minus 120. That will give us negative 96. So we're thinking of two numbers that multiply to give you negative 96 and add to give you positive 10. And we can start to take a look at the factors. So I do want you to get used to using your calculator and start doing some division with negative 96 to see if you can find the factors of that that add to 10. But just for the sake of time, I'm going to go ahead and give you the two factors, and they are positive 16 and negative 6. So we found those factors. We write this in factored form, which is S plus 16 and S minus 6. Our zero product property allows us to take each factor, S plus 16, set it equal to 0, and S minus 6 equal to 0. And S can come out to negative 16, or S equals 6. Again, take a look at the context of this problem, and we're talking about a photo, and a photo is not going to be able to have a negative 16 side length. So in this case, the original side length of our square photo is 6 inches. Let's take a look at the next one, consecutive integers. So the product of two consecutive even integers is 168. So let's try and find the two integers. There is a hint here. So let the first one be n, and the second one, because we're not interested in just the next integer, we're interested in the consecutive even integer, then we will write the other integer as n plus 2. All right, and then it says that the product, so we have to multiply, is equal to 168. All right, so let's write it out. N times n plus 2 is 168. Let's go ahead and use our distributive property. N squared plus 2n equals 168. If we bring everything to the other side, the left side, negative 168 equals 0, and we factor this. So what are the factors? Again, you can start making a list, and the more you do that, the more practice that you get finding different factors, the easier it becomes. But again, I want to give you them just for the sake of time for this video. So what I found here are 14 and negative 12. Again, one of them had to be negative because they have to multiply to give you negative 164. So I have my factors. Let me go ahead and write this quadratic in factored form. So n plus 14 times n minus 12 equals 0. My zero product property, we have n plus 14 equals 0, or we can have n minus 12 equals 0. And in this case, n is negative 14, and over here, n is equal to 12. Now let's consider the context of this problem. Here, we're only looking for integers. So can integers be negative and positive? Well, yes, they can. So we actually have two solutions here. So one integer could be negative 14, and the other integer could be 12. What does that mean for the problem? The two integers, if n is equal to negative 14, then n plus 2 is going to be negative 12. So that's one solution. If n is 12, then n plus 2 is going to be equal to 14. And that's the other solution. So we do have two solutions in this example. All right, we're almost there. We have two others to consider. One is the business launch. So a new startup determines that its daily profit P is related to the number of units sold X by the trinomial that's given. So lucky in this one, we don't have to come up with our quadratic. If the company breaks even when the profit is 0, how many units must they sell to break even? All right, so gives us exactly what we have to do. We have to set our quadratic equal to 0. X squared minus 12x minus 45. Again, we're trying to list all the factors of negative 45, and we can start to go through all the factors that there are, but the ones that I came up with are negative 15 and positive 3. So negative 15 and positive 3 will multiply to give me negative 45, and they will add to give me negative 12. So I go ahead and I rewrite my quadratic in factored form, and I have x minus 15 and x plus 3. Our zero product property is we take each factor and we set it equal to 0. So x minus 15 equals 0. Or we have x plus 3 equals 0. And we get two solutions for x. X can equal 15, or x can equal negative 3. Again, go back and think of the context of this problem. And is a company going to sell negative 3 of any items? That doesn't really make sense. So our solution here is 15 units. Doesn't even really tell us what they're selling, but that is our solution. And we're on to the final problem. Okay, we're going to talk about a triangle now. The area of a triangle is 54 square centimeters. The base of the triangle is 3 centimeters less than its height. So let's try and find the base and the height of the triangle. So here, we're going to start with drawing a triangle. So we have h, which is the height of the triangle, and we have the base of the triangle, which is described as 3 centimeters less than the height. So I'm going to write it as h minus 3. So let's remember our area of a triangle is equal to 1/2 times the base times the height. The area that's given is 54, so we'll write 54 is equal to 1/2. The base here is h minus 3, and the height h. Simplifying some of this, 54 is equal to 1/2 h squared minus 3h. So right away, I don't like this fraction. So what can I do to get rid of it? I can multiply the whole equation by 2 so that it'll cancel out. This is going to result, though, in 108. It's an 8 on the left. And then we'll have h squared minus 3h because this will cancel out that half. Let's rearrange our quadratic and set it equal to 0. So 0 equals h squared minus 3h minus 108. And then again, we have to think of our factors of negative 108, and then two numbers that'll add to give us negative 3. Again, use your calculator, start to find some different factors, but I found the factors for us, and they are negative 12 and positive 9. So let's go ahead and write this in factored form. We have h minus 12, we have h plus 9, and our zero product property will allow us to take each of those factors, h minus 12, and set them equal to 0. H plus 9 equals 0. Our solutions will give us h is equal to 12 and h is equal to negative 9. We go back to take a look at the context of this, which is a triangle, and it doesn't really make sense that we would have a triangle that has a negative height. So that is not an option for our answer. So in this situation, the height of our triangle is 12. If we want to go back and find the base is equal to the height minus 3. That's going to be 12 minus 3. My base ends up being 9. Good, and there you go. So we've worked through these 6 word problems. In the Google Classroom, you have another document of similar word problems to go through on your own. So go ahead and try them, model them after the problems that we just did together, and you should be okay. If you need any help, don't forget to reach out. All right, thank you.